The painter boom, which has a safe working load of 20 tons, keeps the workboat at least 2 meters away from the mothership during recovery. Here you can see it being extended or deployed. We strengthened the original painter booms to achieve this, with the result that their factor of safety was improved by 400%. During recovery, confused sea states result in workboats surging fore and aft, and, when suspended in the falls, this is exacerbated with a rolling motion, whereby the workboat becomes a compound pendulum, as demonstrated here. Both of these motions subject the lifting hooks to severe side loads, and any workboat of this approximate size would necessitate such a twin hook arrangement. The two yellow arms are known as damping arms, were installed to damp the rocking motion along the lateral axis. However, because they exert a force on the sponsor to achieve this, they damage both the sponsor and the sponson carrier. As well as this, because of the violent fore and aft surging motion, the aft arm is known to impact against and cause damage to the superstructure. We concluded, therefore, that a reactive device was necessary to remove the energy that produces this fore and aft movement, the key being in stopping the workboat moving too far aft. This, then, is the actual reactive positioning system, or RPS, which controls the effective length of the painter and is set to displace the workboat forward of plumb by approximately 0.3 meters, thereby setting up a resistive force from the offset falls which maintains the workboat in a stable position. As we only use one control line, that of the painter, we displace the workboat forward by 0.3 meters, which induces a resistive component equal but opposite to that exerted by the painter. By this, movement is all but prevented along the longitudinal axis. The unit is a total line action of 5 meters, which in theory allows the workboat to swing 4.7 meters aft. However, as this would require a force of over 9,000 kilograms acting on the painter, in practice this appears to be constrained to 1 meter aft of plumb. It is worth noting that when the workboat is in the water, the length of the painter line is of little importance, but it is critical when she is suspended in the falls. Hence, it is set to provide this set forward displacement of 0.3 meters whilst at maximum lift. If we compare this recovery, where the workboat is under the control of the RPS unit, with that shown in the second clip, the contrast is obvious. Note the lack of movement fore and aft and along the lateral axis. This is because swaying, the lateral motion, equates to displacement, and the resistive force exerted by the RPS unit resists it. Indeed, whilst the damping arms are not required here, by virtue of the device, should they be so, they always land in the desired position, preventing the aft arm from making contact with the superstructure and abrasive damage to the sponson. For recovery, the workboat crew connect both the painter and the falls, and once connected, withdraw to the wheelhouse to secure themselves in their seats. The Davit operator on the mothership hoists the workboat, and as she leaves the water, she is pulled between 1 to 1.5 meters ahead, leaving her 0.3 meters forward at maximum lift.